We all know the AI roller coaster, right?
Yeah.
1 minute it's brilliant, summarizing a long report perfectly, maybe.
Yeah.
And the next, it's playing Pokemon on Twitch and just failing hilariously at something basic.
Oh, definitely. You see those examples all the time.
It really makes you wonder, doesn't it? Like, beyond all the hype, all the buzzwords,
Yeah.
is AI actually making big leaps forward?
Or is it just, small steps that get blown out of proportion?
Exactly. So that's the core question we're digging into today.
Right. And we're trying to get past the anecdotes, the feeling you get from using it.
We want to look at some really interesting research that's trying to actually measure AI progress.
Yeah, in a totally new way, using real data to see what's genuinely happening under the hood.
Absolutely. And the research we're focusing on comes from the team at METR. That's METR.
METR, right. Model evaluation and threat research.
And their whole thing is basically figuring out what these AI models can really do, especially, thinking about safety and potential risks down the line.
And they look at a whole bunch of them, right? Like Claude, Grok.
Yeah, the different ChatGPT versions, Llama R1.
Yeah.
Sort of the big names you hear about.
And, the standard way people used to test these things was like multiple choice questions, right? Question answering data sets.
The classic benchmarks.
But the thing is, as this METR research points out, the top models now, they often smoke humans on those tests.
Right. They ace them, which kind of makes you think maybe those tests aren't telling us everything anymore.
Exactly. We've sort of hit a ceiling with those metrics. They're saturated almost.
Yeah, they max out the benchmarks, but then you still see them stumble on, stuff that seems like it should be simpler in the real world.
Which brings us to this new research. It's pretty fascinating, actually.
METR developed this whole new data set, a new approach, and it's all about how long a task an AI can successfully finish.
Exactly. It's a shift in focus. Not just how hard is the task, but more like how much sustained effort can the model actually handle.
So they define this task length based on how long it takes a person.
Yeah, specifically human experts doing the same tasks. They looked mainly at things like software engineering, cybersecurity.
Okay, practical stuff.
Practical stuff, yeah. But also some things they called add tasks, just to get a bit of variety in there.
And what I found really interesting is they deliberately didn't try to make the hardest tasks possible.
Right, which is what benchmarks usually do, go for maximum difficulty.
Instead, they focused on tasks that, actually create some value in the real world, especially in software engineering. It's about what AI can do, practically speaking.
Yeah, what it can achieve. And these tasks, they varied hugely in how long they took.
Like how much?
Well, anywhere from like a 1-second quick fix to a pretty substantial 16-hour project.
16 hours. Wow.
Yeah, quite the range. Their main paper on this, the HCAS paper, it even has these graphs showing task diversity. Kind of fun, actually. Shows the breadth of problems.
Okay, so how did they actually collect the data for this? It wasn't just timing the AI, right?
Yeah, no, not at all. It was more involved. First, they had human experts actually do each task.
Okay.
And they calculated something called a geometric mean of the completion times. That gives you a solid baseline for human performance on that specific task.
A geometric mean. Okay, sort of a robust way to average the times.
Exactly. Less skewed by outliers than a simple average. Then, for each AI model they tested, they made it try each task 8 times.
8 times. Why so many?
To get a handle on reliability, consistency. Can it do it reliably, or was it just a lucky shot?
Okay. That makes sense. So you've got human times, you've got AI attempts.
Yeah.
How do you link the task length to whether the AI succeeds?
Right, so this is where the stats come in. They use what's called a logistic curve for each model.
Logistic curve. Sounds technical.
It's basically a way to model probability. Think about learning something new yourself. You get good at the easy bits quickly, right?
Yeah.
But as the tasks get longer, more complex, need more focus, your chance of succeeding perfectly starts to level off and then eventually drops.
Okay, like diminishing returns on effort, kind of?
Sort of, yeah. The curve models that relationship between task length and the probability of the AI getting it right.
So it's not just a yes-no, can the AI do it? It's more nuanced.
Much more nuanced. It's about the likelihood of success for tasks of different durations.
Right.
So that curve lets them say, okay, for this specific model, what's the task length where it has, say, a 50% chance of success? That point becomes a data point on their graphs.
Okay, I think I'm following. So they're tracking for each AI the task length it can handle with a certain probability, like 50-50. And they're seeing how that changes over time with newer models.
Exactly. And they see how that probability drops as the task gets longer, the ones that take humans more time.
So what's the big picture? What do they find when they plotted all this out?
Well, this is the really striking part. The central finding is that these AI capabilities, measured this way by the length of task they can reliably do, seem to be improving at a surprisingly regular rate.
Regular how?
It looks like exponential growth.
Exponential. Okay, that word gets thrown around a lot. What does it actually look like here?
Well, if you plot it on a normal graph, you'd see a curve getting steeper and steeper, right? Accelerating upwards.
Uh-huh.
But the really clear sign is when they plot it on a log scale graph. Exponential growth shows up as a straight line on a log scale.
And that's what they saw. A straight line.
That's exactly what they're seeing, which suggests this isn't just random improvement, it's a consistent accelerating pattern.
Okay, wow. So it's not just getting better. The rate of getting better is speeding up. So what's the key number? How fast is this acceleration?
The headline metric they pulled out is a doubling time of roughly 7 months.
Doubling time, meaning?
Meaning that approximately every 7 months, the length of task that the AI models can perform with a 50% reliability doubles.
Hold on. Every 7 months, they can handle tasks that are twice as long with the same 50-50 success rate.
That's what the data suggests, yeah.
7 months. That feels incredibly fast. Is that figure solid?
It seems remarkably robust, actually. They did a check, what if we demand higher reliability, say an 80% success rate instead of 50%?
Right. Does the trend break down?
Nope. The doubling time barely changed. It shifted by maybe a single day.
Wow. Okay, so that 7-month doubling seems like a pretty fundamental rate of improvement they've uncovered.
It appears that way, yes.
But you mentioned the trade-off with reliability. If you demand that 80% success rate, what happens to the task length the AI can handle now?
Yeah, that's the catch. Reliability costs you complexity, at least currently. So the very best models right now,
Yeah.
they might handle a task that takes a human, say, about an hour with a 50% chance of success.
Okay, 1 hour at 50-50.
But if you say, nope, I need an 80% chance to get this right, the length of task it can manage drops a lot.
How much?
Down to maybe around 10 minutes of human equivalent work.
So from an hour down to 10 minutes just by demanding higher reliability.
Exactly. Big trade-off.
Okay, so fascinating trend. But with that reliability caveat, if this 7-month doubling thing continues, what are the implications? Where does this potentially lead?
Well, one of the researchers, sort of thinking aloud personally, projected that if this trend holds, maybe by around 2028, you could see AI handling tasks that take humans 16 hours in a, quote, mainline version.
16 hours, that's basically a full complex workday for a person.
Pretty much. And once you hit that kind of milestone, well, the implications start getting pretty big.
Yeah, because if it keeps doubling, what's next?
Exactly. You get a couple more doublings in a year. Maybe it handles a week's worth of human work. Another year, maybe a month's worth.
Whoa.
Now, obviously, that's projecting a trend out, which is always risky. But the consistency of the trend so far is what makes people sit up and take notice.
It's not just about one AI grinding away for longer, though, is it?
Yep.
I think they mentioned another angle, another advantage AI has.
Yes, absolutely. And this might be even more important than just doing one long task. It's parallelism.
Parallelism.
Meaning you don't just have one AI working. You could have, as one of them put it, an army of 1,000 models, all chipping away at different parts of a big problem at the same time.
Right, an army. That totally changes the game. It's not just one worker getting faster, it's potentially thousands working simultaneously.
Exactly. Massive parallel processing power.
But how do you manage that? How do you get the best out of the models, especially on complex things? You can't just throw a 16-hour task at it and hope for the best.
No, definitely not. And that's actually a big focus for the METR team. They work a lot on what they call scaffolding and elicitation.
Scaffolding, like building support around the AI.
Kinda, yeah. It's about techniques to guide the AI, help it break down the problem, structure its thinking so it doesn't just fail because it got lost or stuck.
So you're trying to make sure you're measuring the AI's actual capability, not just its ability to follow basic instruction.
Precisely. You want to elicit its best possible performance.
What does that look like in practice? The scaffolding.
Well, they have these methods where the model kind of talks to itself almost, takes on different roles.
Like an internal team meeting.
Yeah, they described it a bit like that.
Yeah.
You might have one part acting as an advisor, suggesting approaches.
Okay.
Then an actor part chooses an action based on the advice. And then maybe a critic part evaluates if that action makes sense.
Huh. So the AI is collaborating internally to figure out the best path forward.
Something like that, yeah. It helps optimize the performance on harder tasks.
That's That's really interesting. It shows how much effort goes into just measuring these things accurately. But how confident are they that these lab measurements, even with scaffolding, reflect what AI can do in the messy real world?
That's the critical question, right? Validation. And they've definitely put thought into that.
How so?
Well, for one, they started testing models on their own internal to-do lists, like the actual tasks the researchers needed to get done.
Okay, eating their own dog food, basically.
Pretty much. And they also compared their approach against another existing benchmark called SWE-bench.
Swibench. Sounds familiar. Software engineering.
Exactly. It's a known data set specifically for software engineering tasks. It includes time estimates, though maybe not with the same detailed human baselining they did for HCAST.
And what happened when they compared? Did the results line up?
The exact doubling rate was a bit different on SWE-bench, actually.
Oh, so maybe the trend isn't so clear.
Well, not quite. The crucial thing was the exponential trend itself. That still showed up clearly on SWE-bench, too.
Ah, okay, so the pattern was there, even if the specific number changed a bit.
Right. They suspect the difference in the rate might be down to how accurately SWE-bench estimates the true time those tasks take. Maybe SWE-bench underestimates them a bit.
So the underlying phenomenon of the exponential improvement seems real, even if pinpointing the exact doubling rate depends on how you measure task time.
That seems to be the takeaway, yeah. The core pattern holds across different measurement approaches.
Did they look at task messiness? Like, real-world tasks aren't always neat and tidy?
They did. They tried to quantify that, like, does the task have a clear right answer? Or multiple paths? Are there tricky parts? Does it need automatic scoring?
Did the trend hold up for the messier tasks, too?
Apparently, yes. Their analysis suggested the exponential trend persists even for the more complex, less clearly defined, more real-world-like tasks in their set.
Okay, that sounds pretty convincing then. It seems like they've really stress-tested this finding.
They certainly seem confident. They mention, all the data analysis, reviewing videos of the humans doing the tasks, checking the AI transcripts.
And diligence.
Definitely. While they're careful, acknowledging there are always reasons to be skeptical,
Yeah.
the overall feeling is that this exponential increase in the length of tasks AI can handle seems to be a genuine, important trend.
With that doubling happening roughly every 7 months.
Roughly every 7 months, yeah.
Okay, so let's bring it back to where we started. That question of AI hype versus reality. Based on this deep dive into METR's research, it sounds like there's actually solid evidence for a real, measurable acceleration going on.
Yeah, specifically in this dimension of tackling more complex tasks that require sustained effort over longer durations.
It's not just hype. There seems to be a quantifiable exponential improvement happening underneath.
That really is the core insight, I think.
Huh.
Current models, they absolutely still have limits. They still do weird, derpy things sometimes.
Like playing Pokemon badly.
Exactly. But the underlying trend in capability, measured this way, points towards something consistently and rapidly improving.
So even if the AI you interact with today feels imperfect, the technology driving it seems to be on this steep upward curve.
It certainly looks that way based on this data.
Which leads us to, I guess, the final thought for you, the listener, to chew on.
Yeah, if this trend does continue, if AI capabilities in terms of tackling complex, time-consuming work keep doubling roughly every 7 months.
What does that mean? What fundamental assumptions do we have about work, about productivity, maybe even about what intelligence is, that might get seriously challenged in the next few years?
It's a pretty profound question, isn't it? This seemingly steady, rapid acceleration. Where does it ultimately take us? Something to think about.